because my system is a bit slow. I don't know why. So I think recording has been started by someone. So no issue. So it's good if you have uh, started the recording. So today we will solve a continuous beam using Kani's method. Okay. So let us take the question first. So the question is analyze the continuous beam as shown in the figure using Kani's method. Okay. So have you solved the problem for a continuous beam using Kani's method earlier? Guys, please respond.
Yes, sir.
Which one we solved?
Sir.
Which problem we have solved using Kani's method? How many supports we did in the previous class? Please tell me. Did we solve this problem earlier?
Sir, last class we have solved.
No, sir.
No, right? Okay. So please pay attention and mute your mics. So this is a continuous beam and this one is 3 tons per meter, and here we have a concentrated or point load, and this is 18 tons, and here we have again a UDA, it is 2 tons per meter. Okay, and this is D, and this point is actually E, but this node is E. Okay, so we have to solve this problem using Kani's method. So before we go to the problem, what is the first step we have to do for solution? What is the first step? Who can tell? Step one is
Then moment.
fixed end moments, right? So fixed end moments. Okay, so now MFAB. What will be MFAB? Please answer. MFAB equals to 3 into, sorry, I didn't mention the dimensions over here. My mistake. This is 8 meters and it is 1.5 I, and this one is 8 meters, this is 4 meters, and this entire one is 2I. Okay, and this is Sorry. Mhm. This is 6 meters and this is I. Okay, this one is okay 2 meters. So who can tell what is MFAB? MFAB equals to 3 into 8 square divided by WL square by 12, right? So 3 into 8 square divided by 12. So it is coming as minus 16 ton meter. Okay. So similarly, MFBA equals to just plus 60 ton meter. Okay. So like this, MFBC. MFBC equals to, it is minus 18 into 4 square, sorry, not 4 square, into 4 into 8 square divided by 12 square, and MFCD equals to 18 into 4 square into 8 divided by 12 square. So this is coming as minus 32. See, I have done this calculations. If my calculations are wrong, please interrupt in between. I'll be happy to correct myself. Okay. Now, the next problem one is MFCD. So MFCD equals to minus 2 into 6 square divided by 12. So it is, how much it is? 2 ton meter. Okay, 6 into 2 is 12 into 6, sorry, not my 6 minus 2, it will be minus 6 ton meter. Okay, similarly, okay, sorry, here I will do that. MFDC equals to plus 6 tons meter. Okay, now MF. Now, who can tell what about DE? What about SPAT DE?
20, sir. 20.
20, yes. But okay, so directly that won't be fixed end moments, that we can write directly as movement due to the cantilever portion. Some issues are happening with my writing pad, so please I'm behaving like this. Just a moment. Actually, my system is getting hanged. Can you see my screen, guys? Can you see?
It's visible, sir, but no, it's not writing, sir.
Not visible. It can't stuck out there only, sir.
Wait, let me join here because my screen has become black.
Yes, sir.
Just a moment. Can you see my screen as black?
No, sir. It can't stuck out where you writing, sir. Movement due to there it will
Ha,
be shown.
ha, ha, ha. Yes, wait. So if you see my screen, wait, just a moment. If you see, sorry. It is white. Wait. Yeah, now it is coming.
Red.
Yes. No. Now it came back. I don't know what happened actually. So in between it suddenly went. So movement due to the cantilever, that is DE. Okay, movement due to the cantilever DE will be. So how much will be DE? So let's call it as MDE. Okay, this is not fixed in moment. It is only the moment due to the cantilever one. So MDE equals to 10 into 2, right? So 10 into 2, so it is 20 ton meter. Okay, now if you see this problem, this end, this one, let me change this one. Okay, what kind of end is this one?
Indeed, sir.
Hinged. Okay, so in at hinged end, what actually should be the movement? The
Zero.
moment should be 0, but here see mf at this moment the moment is coming to as 20 tons meter. Okay, so we will write a note for that one. Okay, so now what we will write, please pay attention here. Okay, since joint D, since joint D, sorry, not O, it automatically took as D, O, joint D is not fixed. Okay, the bending moment, or I am writing BM, the bending moment at D will be due to the cantilever loading only. Okay, so if the joint is free to rotate, if the joint D is free to rotate, then the true end moments are, now what are they? So let's draw the diagram first. So let us say this is the D and D. Okay, so here it is 20 tons meter. This side also same 20 tons meter, and this side it will come as 20 ton meter. So if we see this one, so since the end C, when we are taking this, we are considering it as fixed, because when we take the distribution factor and we calculate the other factors, we generally consider this end to be fixed, right? So this is again 2 tons per meter, and this will be, so here will be a moment of 20 minus 6 equals to 14 tons per meter. So MFCD will be minus 6 plus half of 20 minus 6, right? this will be 6 plus 7, that is 1 ton meter. Please mute your mics. I don't know where are you guys. Okay. So similarly, and but MF, sorry, that rooster was making sound. 20 tons meter. Okay. So if we calculate the restraint moment at each joint, okay, so this is all about the fixed end moments. Okay, this is for step 1. So step 2, what is step 2? Step 2 is, what is step 2? Please tell me.
Distribution factor, sir.
Huh?
Distribution factor.
Distribution factor. Okay. So step 2 is the relative stiffness. So
Hello, sir.
yes,
Can you explain once, sir, how to calculate MFCD?
MSCD. This I told here, right? Wait. This one. You didn't get this one. Are we calculated? See, this joint D, just a moment. This joint D over here, this is what kind of support is this one?
Hinge support, sir.
Hinge support. Okay. So we generally know that for a hinge support, what will be the value of moment across a hinge support? If we have
0.
0, right? So, but due to this cantilever end, what we are saying is this is this one, this one, this one, again this one, and here we have a moment that is 20 tons. Okay, this we are saying. Okay, so we are saying, or we have, it will be like this. Okay, but this is actually not at all possible, because at this end it means something will be there to resist this 20 tons, right? Am I correct? Okay, so
Yes, sir.
this one we are saying that this, whenever we are talking about this joint C, if it is a continuous end, means after this we have support, we have support B and we have support D. So this, so we will consider this and this joint as fixed, right? Okay, so that
Yes, sir.
is what I have done. This is fixed end, this is the D, the end D. This is this, instead of showing this as a simply supported or hinged one, I have showed it to be as fixed end, and I have the same loading I have just put. Okay, now since this is a fixed end, there will be definitely movement across this end, right? Am I correct? Amma, please tell me.
Yes,
Am
sir.
I correct? Right? Okay, so what will be the movement here? Movement, how much movement will be there here? This is given as 6 meters. So how much movement will be there at this point, at this junction? Okay, see what
6,
I am
sir.
saying. Here will be, yes, definitely 6. Okay, so if you see here what I have done. So at joint D, I am saying that here due to this overhang and all, I am having a moment of 20 tons. So this should be nullified by this, some 20 ton meter should be there at this end also. So that the joint D will be a simply supported one or hinged one, whatever you may call. Okay, so that will be that I am saying that here some moment will be there. Okay, this one is D, sorry, this one is D, and this is MFCD and MFDC. So MFCD, what I am saying is, okay, so here we have a moment over here. Sorry, I have not shown this one. Here we will have a moment that is 6 tons meter, right? Due to this one. Where is MFCD? Yes, this one. MFCD will be 6 tons meter. Okay, so now if we consider this one, if you consider the free body diagram, okay, so here already 1 6 ton meter is there. Okay, so this one is like this. So MFCD, sorry, MFCD equals to this minus 6 plus half of this 20 minus 6 again. Okay, so that becomes minus 6 plus 7 equals to 1 ton meter. So MFCD, that is the final end moments or final fixed end moments at CD is 1 ton meter, and MFDC will be simple. MFDC will be only minus 20. Sorry, plus 20 ton meter. That's it. Okay. So I hope it is clear. Amma, even I don't know who was asking this question. Amma, is it clear
Yes,
to you?
sir.
Okay. Okay, so you can see my screen, right?
Yes, sir.
Okay. So in the second step, we are going to calculate the relative stiffness and the rotation factors. Okay, so all of you know the relationship between the rotation factor and the distribution factor. Okay, so let us draw the table. The first one is joints, then member, then relative stiffness, then total RS I am writing for relative stiffness, total RS followed by the distribution factors DFS, and this one is a rotation factor. Okay, now if we see this diagram over here, so we will have we will have joints. What are the joints? We have joint B and joint C, right? So joint B and joint C. Now what are the members connected with joint B? BA, BC. Okay. Now what will be the relative stiffness for the for BA? For BA, what will be the value of relative stiffness? So it will be BA. A is fixed, so it will be 4EI by L. So again, I is 1.5I. Okay, so 4 into E into 1.5 divided by the length is 8. So how much it is coming? 0.75 EI. Okay, so similarly, so please all of you check your figures. I'm writing the values directly. Okay, this will be again since end C is a continuous N1, so again it is 4EI by L, so it is 4 into E into I is 2I by how much is L? L is 12 meters, so it is coming as 0.67 EI. Okay, so let's do this one again. So this will be CB, CD. Okay, so for CB it will be same. This same value will be there. It is 0.67 EI and CD will be 3 EI by L is 6 meters, so it is 0.5 EI. Okay, so the total EI is 1.42 EI for joint B, and for joint C it is 1.17 EI. Now the distribution factor will be 0.528. For this one is 0.528. All of you please calculate this one on your own, okay, because it is 0.75 divided by 1.42, so 0.528, and this is 0.472 for BC. Okay, now the distribution factor for CB is 0.573 and the distribution factor for CD is how much? 0.427. And one more thing guys, in order to know whether your answer is the distribution factor value is correct or not, you just for every joint you just add these two values. You need to add these two values. Sorry guys, it went off. Oh my goodness. There is nothing here. Oh, sorry. It is there. It is there. Thank God. Yes. So please remember that these, if you add these two values, the sum will be how much? How much will be the sum?
1, sir.
1. Similarly, if you add these two, the sum should be always 1. If your sum is not 1, then your answer, these two values are not correct. Okay, so now what will be the value for rotation factor? It will be minus 0.528 divided by 2. So that is coming as minus 0.264. Similarly, minus 0.472 divided by 2, it is coming as minus 0.236. Similarly, this one is minus 0.573 divided by 2, it is coming as minus 0.2865, and this is minus 0.427 divided by 2. Okay, so this will be minus 2135. Okay, so these are the distribution factors and the rotation factors for the two joints B and C. Okay, so now the next step will be, what will be the next step? What will be step 3? What will be step 3? Step 3 will be a rotation contribution. Okay, so let's make this one here. So this is A. This box is for B, and this one is for joint C, and this one is for joint D. It is like this. Okay, so this is A, this is B, this is C, this is D. So now what I should write here? How much is MFAB? MFAB is
Minus 16.
AB equals to minus 16, right? MFBA
16.
yes, plus 16. MFBC
Minus 32.
minus 32. MFCB
Plus 16.
plus 16. MFCD
Minus 6.
minus 6. MFDC. Wait, here, there I am unable to write. MFDC will be MFDC equals to 20 again. Okay. So now here will be, I'm changing the color. This will be M dash AB. This will be M dash BA. This will be M dash BC. This will be M dash CB. This will be M dash CD. This will be M dash BC. Okay. So
Sir,
here in, yes,
we have two values now, sir, for MF CD and MFDC. After considering the
no,
cantilever load.
Final will be, wait. Yes, the final value will be taken, not minus 6. You are correct, Amma. The final value, sorry, this one will be MFCD. This will be 1. This value we will consider 1, which we calculated at the end. And this MFDC, whatever we calculated and at the end, that is supposed to be taken. This will be 20. Okay. So you just check this one. Here we have calculated. You see. Here we have calculated. Sorry, then this is my mistake. Here it is 1 ton. So this will be that 1. Okay, and this MFDC will be 20, whatever we have calculated. Okay, so now what will be the value here? Here it will be MFBA plus
MFBA plus
MFBC,
MFDC.
MFBC, right? So I'm changing the color. So it is plus 16 minus 32 equals to minus 16. Okay, so I'm erasing this part. I am simply writing it as minus 16. Minus 16. Now, MF, what value we will write here? Who can tell? It will be MFCB plus MFCD. Okay, so it is 16 plus 1 equals to 17. So I am directly writing the value as 17 over here. Okay, so this is 17. Now I need to write the rotation factor values. Okay, so the rotation factor is, how much is the rotation factor for BA? Minus What is the rotation factor?
0.26.
Minus 0.26. So it is minus 0.264, right? Minus 0.264. Minus 0.264, and it is minus 0.236. Minus 0.236. This will be minus 0.2865. Minus 0.2865, and this will be minus 0.2135. Minus 0.2135. Okay, so I hope everything we have written it here. Okay, so the next step is, what will be the next step? The next step will be the different cycles. Okay, so let us assume that this m dash AB is 0 for the first cycle, and m dash DC is 0 for the first cycle. Okay, because then only we can write the values, or then only we can find the value. So sorry, not MFAB, this m dash AB will be considered for joint B. Similarly, m dash CB will be considered for this one, and m dash BC will be considered for joint D whenever we are calculating, and this one will be considered here. Okay, so now let's write the cycle 1. Okay, so I'm writing it here. Cycle. Let us calculate the first cycle. So m dash BA, what will be? This is m dash BA. Okay, so m dash BA, what will the value of m dash BA equals to? Minus 0.264 into what? Into this minus 16 plus m dash AB plus m dash CB, right? Okay, m dash AB plus m dash CB. Okay, so m dash AB, the current value is 0, and m dash CB, there is nothing now. Okay, so this is coming as, how much it is coming? 4.2.
4.224.
0.224. Yes. Please, Amma, correct me if I'm wrong. No issue. Okay. So m dash AB is this one. So m dash BC will be, see, whenever we are doing such kind of problem, okay, just remember that when you are calculated this one, okay, for the first BA, you just simply take these values and multiply it with the distribution, the rotation factor of this one. Okay, so minus 0.236 into 16 minus 16 plus 0 plus 0. Okay, so this is coming at plus 3.776 meter. Okay, so similarly for m bar
Sir,
m bar CB.
sir,
Yes.
sir, can you explain
Good.
once again what m dash BA? How it
M
will?
dash B.
Yes, sir.
Okay, so M dash BA, M dash BA equals to the distribution, sorry, the rotation factor of BA. This is the rotation factor of BA. Okay, so rotation factor of BA into M bar AB, and m bar a, sorry, this one minus 16 plus, okay, I'm writing as this one, it is this one is this one, and at this one there is, see, in the cycle 1 no value is here, so we can assume this 0 value as here. Now did you get this one?
Yes, sir.
Govardhan?
Yes, sir. Thank you, sir.
Okay, So similarly for BC, for same BC, for BC part, we will only multiply, I'm changing the color, we will only, instead of this one, we will multiply it here. Instead of 0.26 for this one, we will multiply 0.236. This is the shortcut to remember this one. Okay, then this one is here, minus 16, and same this value will be here and this value will be here. And in subsequent cycles, the value of this M bar CB and M bar AB will change. Sorry, not BA, yes, the M bar AB, it will change. Okay, subsequently it will change. Okay, basically these two values will change. Okay, these two values will change. Okay, so now if I consider for M bar CB, if I want to find out the value of M bar CB, so M bar CB will be this one. Okay, so minus 0.2865 into this value over here, 17. Okay, then M bar BC, did we calculate it? Yes, it is 3.776. Okay, this one we will put here, 3.776. M bar BC is this one, M bar BC plus M bar DC is 0. Right, no value is here in the cycle 1. We are considering at cycle 1 it is 0. Okay, so if you do the total will be, how much will be the total? Minus
Minus 5.95.
5.23 ton meter. Okay, so next one is M bar CD. Okay, so M bar CD equals to, similar to this one, this step, we will only replace this one. Okay, so it will be minus 0.2135 into 17 plus 3.776 plus 0. So this is coming as minus 4.4356 ton meter. Okay, so the first cycle is over, right? So next, so after the first cycle is over, what we need to do? I need to write the value of BA, M bar BA, M bar BC, M bar CB, and M bar CD. Okay, so M bar BA, it is 4.224, 4.224, and M bar CB is minus 5.9523. Okay, M bar CB, sorry, this is 3.776. This is minus 5.9523, and this value is minus 4.4356. 4.4356. Okay, so this is the cycle 1. This is the cycle 1. Next we will have cycle 2. So till when we need to go we make the cycles till these values repeat. Okay, so now I'm erasing this one, the cycle 1, I'm erasing from here. Okay, now we will I will write here the next cycle. Again, this one delete. Okay, so now I will write cycle 2. Cycle 2. Okay, so similarly again here m bar. Now please tell me what will be m bar BA. M bar BA equals to again minus 0.264 into minus 16. Then m bar AB is, how much is m bar AB? M bar
0.
AB is 0. 0. Okay. Now what will be the next value? M bar CB.
Bar CB minus 5.9523.
CB how much? 5.952. Okay. So how much it is coming? It is coming as 5.1807 ton meter. Okay. So the next step, next one is M bar BC. M bar BC. So as I told, we will simply 0.236 into the same thing, exactly whatever we have written, we will write it here. So no need to confuse with this one. Okay. So that becomes M bar BC. Sorry. This value is not this one. This is not this one. This one is 5.79 5.7954. This is 5.1807 ton meter again. So the next value is m bar CB. M bar CB will be 0.2865 into 17. Then this value, then plus 3.776 and plus this value, so plus 0. So m bar CB equals to, how much is m bar CB? It is equals to minus 6.3547 ton meter. So similarly, m bar CD equals to minus 0.2125 into 17 plus 3.776 plus 0. So this becomes minus 4.7355 ton meter. So we will write all these values. This is again 0. This is 5.7954. This is 5.1807. This is minus 6.3547. This is minus 4.7355. This is again 0. So here the cycle 2 is over. So next cycle, see, now these values are not same. The corresponding two cycle, the value of the two cycles are not same, right? Is it same? No. Okay, these two values should match. These two values should be same. These two values should be same. Okay, means all these two values should be same. No doubt here it is 0, here it is 0, but these two other values are not coming as same. Okay, so we'll go for another cycle, cycle 3. I hope all of you are well aware about this method. Have you studied this Kani's method in essay 1?
Yes, sir.
Yes, okay. So now the cycle 3. Okay, so I'm writing here cycle 3. Okay, so in cycle 3, m bar BA. M bar BA equals to minus 0.264 into minus 16. Then this value we will take. So sorry. This value and this value and this value we will take. Okay, so minus 16 plus 0, then this is minus 6.3547. Okay, so this is coming as 5.9016 ton meter. Okay, so m bar, next one is m bar BC equals to the same minus 0.236 into minus 16 plus 0 minus 6.3547. Okay, so this one is coming as 5.2757 ton meter. So m bar CB, m bar CB equals to minus 0.2865 into 17, then this value plus 5.1807, then this value it is 0, equals to m bar CB, it is coming as minus 6.3819. Okay, m bar CD equals to, simply we will change the distribution factor, 0.2135 into 17 plus 5.18, this is 0.1807 plus this is 0, not 6, this is also 0. Okay, so this is coming as minus 4.7559 ton meter. Okay, so now we have written all the 4 values. So these 4 values we will write. This will be 0, this will be 5.9016, this is 5.2757, this is minus 6.3819, this is minus 4.7559, this is 0. Okay, this you can make a line over here to differentiate. So now still again there is variation in the values, so again we need to go for cycle 3, and I'm telling you from the starting itself that for this problem, since I have solved this problem, for this problem we need to go till cycle 5. Okay, so till cycle 5 we need to go. Okay, so the fourth cycle, this will be now cycle 4, and this value, it is, this value will be 0, this is also 0. Okay, this is 0, I told this one. So cycle 4, the fourth cycle. Okay, so m bar BA equals to minus 0.264 into, before that let me remove these. Why these zeros are coming automatically? The worst part with this Microsoft whiteboard is this one. So it will automatically consider some, if you draw O or something, it will consider it as circle. Okay, so it is again minus 16 plus this value is 0, and which value it will take? You can see from here, it will take this value
minus 819.
minus 6.3819. Okay, so this one is coming as m bar BA is 5.9088 ton meter. So similarly for m bar BC equals to minus 0.236 into minus 16 plus 0 minus 6.38, this is 0.189. So this will be m bar bc equals to 5.2821 ton meter. So similarly, this will be m bar cb. M bar cb equals to minus 0.2865 into 17 plus this value we will take, okay, 5.2757 plus this value is 0, right? So it is 0. So this is coming as minus 6.3838. For me it is coming 6.3838. Okay, now the next value is m bar cd. M bar cd, right? M bar cd equals to minus 0.2165. Something is okay, sorry, nothing. So minus 2 point, this is 17 plus 5.2757 plus 0. So this is coming as, how much is coming? This one is coming minus 4.7572. Okay, sorry, not 5 cycles, 4 cycles will be required. Okay, because the values are matching now. So it is 5.9088. This is 5.2821. This is minus 6.3838. This is minus 4.7572. Okay, so somewhat, see, these two values are almost, see, 5.90, 5.90, 5.27, 5.27, 6.38, 6.38, 4.75. This is also 4.7572. Okay, so I'm writing this one. This is minus 4.7572. So see, this 4.75, 4.75, it is matching. Okay, so we can stop here and we will calculate the final n moments. Okay, now what will be the final n moments? So that will be so the final n moments. So this will be step 4. Okay, step 4 is final n moments. Okay, so what will be the final n moments? Who can tell? Or we will calculate this one later on, because it is already 6 o'clock. What do you want? Shall we calculate now, or whatever you say, we will do that?
Tomorrow we will solve, sir.
Okay, so this final n moments we will solve in the next class. Okay, thank you guys, and before you leave, I need your attendance, please.